Okay, we'll do, I think, 3 bonus problems on top of your mark. First one, let's consider a square cross section, 15 millimeters across. Through the middle, we'll apply a turning moment, and that can have a turning moment of 10 kilonewton meters. And I want to know what is the normal stresses at A and B. What do I need to do? Okay, so first of all, I need to split up my M component. To find some axes, we'll have X going off in this direction, Y in that direction. So we'll be doing My in this direction and Mx in this direction. Both of them are moving around by 45 degrees. So Mx equals My equals 10 times cos 45. So I'm swinging through 25 there, swinging through 25 there, it's like a force. And that equals 5 root 2. Oops. If we put that into our calculator, calculator will do the work for us. 7.071. We want 5 sig fig, 2, and another one. Okie dokie. So that's the M split up. What do we want to do next? I'm simply going to use the bending equation to find my stresses. So stresses, and so I imagine that I've now got a turning moment here. So if this is going in this direction, yeah, it's going to be turning in this direction. This one here is going to also be turning in this direction. So you can see which way this is turning. So that can be split up into a component that's turning down in this direction. This is turning like this, so it's going to be split up in this direction. So what's the effect going to be on these components? Well, you can see that this, if we're now looking at our two components of turning moments, this one here is kind of pulling at this point B. It's pulling it away from the page, whereas this turning moment is pushing it into the page. So the overall stress that we expect to see at this point here is going to be 0. So that one we can work out just by looking at the problem. What about A? Well, A, we can see that our turning moment here, this one is going to be pulling it out, and this one is also going to be pulling it out. So the overall stress is going to be a combination equally of these two values added together. Right, we just need to find out what the stress is going to be from the engineer's bending equation. So we're going to use this My divided by I equation. So let's work out what stress is created, for argument's sake, just for the top one. Okay, so for the top one, the stress for, that's going to be experienced at A is going to be given as 7.0711. What's the distance from here to here? Well, that's going to be 25 millimeters, so 0.25. And what about our I? So that's the I for the cross section. So we want to do a 12, and well, we're going to put in a b d to the power 3 term there, which, as it's square, that's going to become d to the power 4. So we want to put in 7.0711, 0.025 divided by 1/12 times by 0.05 to the power 4. Right, so the stress created by this component in the y direction will be given as this value here. I'll label this as stress 1 component. So what's that work out to be? 0.70711 times by 0.025 divided by, let's open a bracket, 1 divided by 12 times by 0.05 to the power 4. Close the bracket. Close the bracket. So that equals, well, don't forget we're working in kilo, so let's stick on 1,000. So that equals 33.9 megapascals. Now, so that's going to be the stress created by this one here, pulling away at the A, and this component here will also be pulling away at the A, same direction, so it's going to be twice this value. So the stress will be, happens to be both components, so we want to times up by 2, which gives me 67.9 megapascals. So obviously I simplified this problem down. This is the first bonus question. I've made my square symmetric, make that simple, split up the components, but you can see the important thing is to get a handle on whether you're pulling at that particular point or if you're pushing into that particular point. So you've got to imagine that this is going to be turning. If you're not told which way it's turning, then just make it up, and then perhaps you might have to switch your signs around to compare to the final answers, but other than that, everything should be fine. So that's the first bonus.